Hi, my name is Hannah Roberts, and I'm in lab on Monday nights from 6 p.m. to 8:55 p.m. And in this lab, we're going to be doing thin layer chromatography, also known as TLC. And we're going to be using this to separate non-volatile mixtures. The two liquids that we're using in this lab are ethyl acetate and heptane. And after the sample has been applied on the chromatography plate, we're going to use a solvent or solvent mixture, also known as the mobile phase, to be drawn up on the plate via capillary action.
Okay,
So the jar here is filled with 8 milliliters of heptane and 2 milliliters of ethyl acetate. There's also a piece of filter paper in the jar, and then the solvent is at a good level for TLC elution. The filter paper that's added to the jar is just at the bottom of the solvent. The bottom of the filter paper is reaching the solvent. And then I'm going to shake the ethyl acetate and heptane, which covers the filter paper. And then next step, I will add the chromatography plate after marking it. This is the chromatography plate. It's marked in pencil with 2 small holes. On the right side is fluorine, and then on the left side is fluorinone. Okay, so I'm checking the capillary tube to make sure it's not jagged. It looks pretty good. And so on the right spot here, I'm going to add fluorine, just like a pinprick. And then I'm checking this new capillary tube that I'm using for the left side. And then on the left side, I'm going to be using fluorinone. It's going to be the same thing, just like a little small dot of it.
Now we're going to let it dry. Thank you.
So I'll be removing the cap from the jar to put in the chromatography plate. The chromatography plate is placed vertically in the jar, and the white side of the chromatography plate is facing towards the filter paper. And then I will replace the lid. So the pencil line was initially underneath the solvent level, but now the solvent is going up the chromatography plate due to capillary action. And once the liquid reaches about 80% of the plate, I'll remove it and mark it immediately with pencil. Now the chromatography plate is at about 80%. The liquid has traveled up about 80%. So I'm removing it from the jar, and I'm going to promptly mark it with pencil. So this is where it's at with 80%.
Okay, so now we're going to go put
the edge of mine.
No, that's okay though.
And then I lightly marked with pencil where the liquid traveled to due to capillary action. So it's only probably been about 30 seconds and the liquid already evaporated from the chromatography plate, and so that's why you have to mark it immediately with pencil. So this is the eluted plate, chromatography plate, and we're going to be placing this underneath a UV light.
Like, I can't even see shit, like, the whole time. What?
So this is underneath the UV light now. I'm going to take a pencil and lightly mark each of the circles so that I can see them whenever it gets taken out of the UV light. On the left, we have fluorinone, which traveled up the chromatography plate, and then on the right, we have fluorine, which traveled up the chromatography plate. So now that you can see, without the UV light, how the fluorinone and fluorine both traveled up the chromatography plate. Next up, we will be taking RF measurements of how far the fluorinone and fluorine traveled. Okay, so we're going to measure from the first spot to where the UV dot was for the fluorinone, and then on the right side we're going to measure from this dot to the UV dot for fluorine, and then we'll measure from the bottom to the top of the entire plate. So for fluorinone, measuring from center to center, it's about 1.5 centimeters. And then from the bottom to top is about 4.25 centimeters. And then next we'll be measuring the fluorine. So measuring from circle to circle, their centers. Fluorine traveled about 2.46 centimeters. And then measuring from bottom to top again, it'll just be 4.25 again. So to find the RF value, we're going to take the distance that the spots moved over the distance that the solvent moved. So here, these are the calculations for RF. The fluorinone, I used the RF, the distance that the spots moved, which was 1.5 centimeters, over the whole distance that the solvent moved, 4.25 centimeters. And the calculated value for that is 0.353. Then for fluorine, the RF value is calculated in the same way, 2.46 centimeters, which is the distance that the solvent moved, that the spots moved, over 4.25 centimeters, which is what the solvent moved, and then the calculated value equals 0.579.